Yes, good evening, class. Thank you so much for connecting and tuning on to Metric Up. We just want to continue with our unit chapter of mid-latitude cyclones. So, without wasting any time, we just want to look at the areas of development of mid-latitude cyclones, conditions necessary for their development. We also gonna look into the various stages and the various stages of development of mid-latitude cyclone. So I'm sure that I've explained the introduction. In the introduction, I've explained to you what are mid-latitude cyclones. I've made a clear introduction. So areas of development of mid-latitude cyclones, you understand that they are located in the middle or temperate latitudes, which is between the latitude, between 30 and 60 latitude, 30 and 60 degrees latitude, both north and south of the equator. So what I want you to understand is that mid-latitude cyclones, they are found in the middle or temperate latitudes, which is between 30 and 60 degrees north and south of the equator. So they form at the polar front where warm westerlies and cold polar easterlies meet. Remember, we said that they are driven by formation of a front, which is actually caused because of the two air masses that we said that they are meeting, uh, uh, resulting in the polar front forming. So remember that in this regard, what is happening is that the differences in the air masses results in this front developing, and hence we have got the stationary front that is found there, and then at the end of the day, we have got two parallel air masses that are moving towards each other. In that respect, I'm sure you can be able to refer back to that presentation of the development, I mean, on the introduction of uh, mid-latitude cyclones. So, what are the conditions necessary for their development? Conditions necessary for their development. I'm sure that you should understand that they must be code A, they must be code polar A mass from code polar easterlies, which we are saying there is this core A mass, which is one, there is a code A mass, there is a code A mass that is existing or that is coming here. We have got the code A mass. So because of that, the code A mass is one characteristic there of the air mass that we are having. It's one, and then we are having also the warm tropical air from the warm westerly winds. So what we are saying is that there are two air masses that are meeting, the cold polar easterlies and what the warm tropical westerly winds. So as these air masses are moving towards each other, we have got we have got this condition being one of the key factors that must be there. The contrasting characteristics of the air masses being present. And then also number two, there is a cause. I mean, we are saying this caused an imbalance in energy distribution because of the difference in temperature, an imbalance in energy distribution, which actually, I'm sure in the introduction, I told you that the imbalance of the energy, it is actually the one also which causes the global air movement. To say the temperature variation results in the creation or in the formation of a low and high pressure cell. So what we are saying is that air must move from high to low pressure. So an imbalance in energy distribution, it is also because of the differences in the temperatures. So the differences in wind patterns direction contribute to the resultant formation of this what we call it also results in the formation of this mid-latitude cyclone. So still on that, I'm saying you need to understand that uh, there is also other factors that I want you to look at, which is to do with what you call upper air diverges. And then this is required to move air that is ascending from below. It makes continual ascent possible. In regard to conditions necessary, it is also supposed to be there, is supposed to be something that trigger the development of a low pressure center. That is one thing that you should also understand. that there must be something that should trigger the development of a low pressure center. So in other words, I'm going to illustrate also what is it? When I'm looking at the general characteristics, you shall see that in the upper atmosphere, the air diverges and then it converges on the what? On the lower, on the, I mean, by the, on the ground. So what happens is that there are these aerodynamic systems, which as students, we are quite expected to understand and know that when the air rises, it does what? It cools down, and then as it falls down, it warms up. So we are saying something must be there that must trigger the development of a low pressure center that must be there. So in this regard, we also need to ought to understand that the divergence of air in the upper atmosphere is required to move air that is ascending from below. So then the air is circulating. When it diverges in the upper atmosphere, it creates a propelling motion that would allow the movement, or that would allow removal, that would allow to move or remove air that is ascending from below, and then to make a continual movement possible. So that is one key thing that I want you to understand on conditions necessary for the development of mid-latitude cyclone. Uh, there is also this part, why are they more prominent in winter over South Africa? This is one key question to say, why are we having mid-large cyclones so quite dominant in winter over South Africa? It is also because of the migration of the ITCZ that I have explained in the previous chapter, that the ITCZ, it migrates, and then this migration, we are saying, and with it, the migration of the high pressure cells, it results in the low pressure systems moving over southern part of South Africa. When I explained the concept of ITCZ, I explained this as well, that the ITCZ is not stationary, it migrates. So with that in mind, you are able to relate and understand that that is why we have got what? We have got so prominent and dominant of mid-large cyclones over South Africa. Uh, Question next, we are saying, or what is it, the characteristics necessary for the development of mid-latitude cyclones? What are the characteristics necessary for the development of the mid-latitude cyclone? One, extensive low pressure at the center of the system. Extensive low pressure at the center of the system, it must be there, that at the center of the system, there must be a low pressure center. And then clockwise movement of air in the mid-large cyclone in southern hemisphere. In this regard, I want you to reflect, I want you to understand that the air blows from the high pressure towards the low pressure from all directions in actual fact. However, we are saying as the air moves towards the center of the low pressure, it is deflected by the Coriolis force. Remember that the Coriolis force that we talked about last time, also mentioning in passive, we said that, I explained to you that that is the effect of the Earth's rotation that causes wind to be to be deflected to the right in the southern hemisphere, and also to the to be deflected in the to the left in the southern hemisphere, and then to the right in the northern hemisphere. So with that in mind, what is supposed to be understood is that the deflection of the air, we are saying to the this deflection of the air, it is caused because of the what? It is caused because of the Earth's rotation that would cause deflection of the air in various directions with regard to the sphere that the air in which this movement is taking place. So I just want to illustrate to you this, is to say that a low pressure center that is taking place in what? In a southern hemisphere. I want you to know and see that this how it looks like. The low pressure center that is taking place in a what? In a southern hemisphere. The one thing that you should know is that there is also the isobars oval and so forth. But one key area that I want to demonstrate now is this thing, which I would want you to see, uh, the isobars, the issue of the isobars here, and then you can be able to relate and see what we want to, what I want you to look at. So we are saying at the center we have got what? we have got low pressure, which I can give to say something like maybe 900. We can say 992. We have got, we can say the next one is going to be 996. And then I can have maybe 1000. These figures that I'm giving here, class, they are referring to the what, to the pressure. We are marking areas of equal pressure that are shown by the circles or the bars that I'm showing there. So what we are saying is that this case, there is the deflection of wind, which we say that this deflection uh, is to the left in the southern hemisphere and to the right in the northern hemisphere. And then which result in cyclonic air circulation is clockwise in southern hemisphere. Therefore, the cyclonic air circulation in southern hemisphere is what is clockwise, and also anti-clockwise in what, in northern hemisphere. So if it is clockwise, therefore we have got our bars, which we say air moves from high pressure to low pressure. In that respect, I want you to look at this to see that there is these arrows that are coming, which has to demonstrate that air is moving from high pressure to low pressure. Air is moving from high pressure to low pressure. I'm just using a different color just so therefore this can just show. You see, what I'm seeing, what I want you to see is that air is moving in a clockwise direction. There is a clockwise direction that is taking place. There is a clockwise circulation of air that is taking place there. So here I can therefore write and indicate that we have got what? We have got an L. This L is referring to a low pressure center. That refers to what? This is a low pressure center there. We have got a low pressure. We have got a low pressure center that is shown here by an L that you are seeing there. So air is moving from a high pressure, which is from the outer iso bars there that you are seeing here, and then it is entering to it is pointing to 992, and then it's coming from 996 going towards the low pressure center there. So what this is, air circulation, which is taking place in what? There is the Coriolis force or the deflection of the wind results in what? In a clockwise air circulation. I can maybe say that this is a plan view of cyclonic circulation in the southern hemisphere. I can say cyclonic circulation. I can say cyclonic circulation that is taking place in the southern hemisphere. Cyclonic circulation in southern hemisphere. Because one other time you might be asked to give that is to say demonstrate that cyclonic air circulation that is taking place, or it can be given that you need to know whether it is southern or northern hemisphere. So the Coriolis force is said in southern hemisphere, it deflects the air to the left, which result in a clockwise circulation or air, clockwise movement of the air. That is shown by the arrows that I have shown you here. These arrows are showing clockwise movement. Clockwise movement of air towards the center, which we say that the center is what? Which we say the center is a low pressure center there. So I wanna just quickly want to show you how does it differ therefore with what? With the cyclonic circulation that is taking place, that might take place in the what? That might take place in the northern hemisphere. So in the northern hemisphere, you should see that the cyclonic circulation, we have got our isobars, of course, as usual. We have got our isobars that are just as usual there. So I can maybe want to label to say that we still have our pressure being like 992 there, 996, and then I can say that I've got 1,000 there. So what is happening here is that the movement now is different. We are saying the movement now is different. As you can see, this air was circulating like this. So in this case now, our S is circulating in an anti-clockwise direction. If you can see that this is an anti-clockwise air movement that is taking place. Air is moving towards the center in an anti-clockwise direction. So the arrows are demonstrating that A is going to the center, but in an anti-clockwise movement. So then I'm saying this is this is the planned view also of cyclonic circulation in what in northern hemisphere. So uh cyclonic circulation in northern hemisphere in northern hemisphere, which you can say in northern hemisphere. So class, please understand, check the movement, check the arrows, how they are moving. They are totally opposite. I'm saying the diagram, that is the second diagram which I drew here, it actually demonstrates and illustrates to you that this is what anti-clockwise direction. There is an anti-clockwise direction that is taking place in diagram B. Its diagram B, it represents what anticyclonic circulation, or it is demonstrating the anti-clockwise movement, which takes place in what? In the northern hemisphere, which is like that. And then I can maybe say this is A. It is showing the what? The clockwise movement, which is happening in what? In northern, I mean in southern hemisphere. So the clockwise and the anti-clockwise is defined by the shape of the order in which the arrows are moving, the direction from which the arrows are moving. As you can see there, these are showing, they are showing what? They are coming from an anti-clockwise towards the center. They are moving from an anti-clockwise direction and then entering to the what? To the center, which I can say you can see there. So that is one thing that I wanted you to take note of. So obviously, take note of these anti-clockwise and the clockwise motion of the air that moves in the two hemispheres, as I've mentioned now. So we can continue. We can continue. So having said that, other factors that we need to look at is that the general the general characteristics necessary for the development of mid-latitude cyclone. There must be a presence of a warm front. We have got a cold and warm front. So in an anti-clock, in the mid-latitude cyclone, there is a warm front, and then there is a cold front, which I mentioned previously, and I explained how are these air masses, how these fronts are formed, which air mass is moving towards where is it going. So the warm front, which we say that the warm air is moving towards a cold air, and then it overtakes that cold air, and then it actually overrides that cold air, resulting in the formation of the warm front. So we also obviously have a warm sector. I defined the warm sector and the cold sector in the previous section, an area of warm air behind the warm front, which is a warm sector that when the front is moving, we have got a warm sector, which is a zone that is occupied by warm air that is behind that warm front. And isobars, I mentioned already that they are also over moves from the west to the east because it's driven by we are saying mid-latitude cyclones are driven by westerly winds. They are driven by westerly winds, hence they move from the west to the east because they are driven by strong westerly winds. I'm sure again that has been defined and explained in our previous presentation. It affects the western side of the continents in the middle latitudes, and then diameters are between 1,000 to 1,500 to 3,000 kilometers. That means to say that they are big. We are talking about from the center, from one side of the cyclone to the edge of the other side, its diameter across, or that total distance across it, is from 1,500 to 3,000 kilometers. That is quite very big, some kind of a cyclone that we are talking about. It travels at a speed of about 50 to 60 kilometers per hour, which is actually very fast again. We are saying in an hour, it can cover a distance of 50 to 60 kilometers. And the lifespan of the system is almost or between 4 to 14 days, which is also quite big, is like relating to how these cyclones are severe and destructive. So if it's something that can last to from 4 to 14 days, we can relate and see that that is also why we also find them very destructive. And usually they occur in families, two or more, where we say one moves and the other one follows. We always find them in what? In families. They usually occur in families, these mid-latitude cyclones. Uh, they form all year, but better developed in winter from April to October in South Africa. I have also explained why they must also have such factors or such things. So I'm gonna let me quickly just talk about the development, the stages of development of mid-latitude cyclone. The stages of development of mid-latitude cyclone. Uh, in that case, sorry. One other thing that I was just thinking that I mean I should mention, which is in regard to this in general characteristics, is that the air converges and rises. This I want to just demonstrate it also, because at certain times geography is too much clearer when it is involving diagrams. So we have got something like this, which I can either just want to break it small. I can break it into small there. Break it. These are just arrows that I want to show you. How is this cyclone occurring? So we have got something like this. And then what I'm saying is that in this direct, on the surface, we have got converging and rising air. These arrows are showing converging and rising air. The air, it converges and it rises. So what I want you to see is that we have got diverging air at the upper atmosphere. Diverging air, it has to occur there in the upper atmosphere, and then we have got converging and rising air, converging and rising air on the what? On the ground. Converging and rising air, converging and rising air. And don't forget that this, we are saying, this is just taking place on the earth. It's just on the earth. This is our earth there. We can say that is our earth. It is our earth there that I want you to see and check on. So we have got all this. Now we are saying it is rising air, and then we also have low pressure. Obviously, we have got low pressure there. We have got our low pressure, and I want you to understand to say, as I explained there, we said that air converges. There is a condition that takes place in general characteristic that I want you to look at. This air, it is the same air which we are saying that it rises on the surface of on the earth's surface. The air converges, as to say it moves towards each other. We see this air, is converging because we are saying air masses are moving from opposite direction towards each other, and therefore they rise up. So the air converges and rises at the surface of the earth and diverges in the upper air or in the upper atmosphere. So what you can see is that these patterns of convergence are sent, and these patterns of the convergence ascent and divergence also, which is a section which can be seen in both hemispheres. That are one thing that I want you to understand in that regard. And so it is this air mass which we are saying as it rises, it cools down and then it has to fall back again. And then when it falls back, it is going to come and feed into the system again to continuously sustain the rising air that we talked about. So the air diverges in the upper atmosphere and then it falls back, it falls down, or it descends, it falls down, which we say it what it there is it descending air, descending dissenting air, it comes and feed back into the system again. So therefore, it will come and continuously feed and support the system to keep on happening and sustaining the life of the tropical cyclone, I mean, of the mid-latitude cyclone. So please understand that there is divergence in the what in the upper atmosphere and then convergence in the what in the on the earth surface. That is one thing that I want you to take note of in terms of the basic characteristics and conditions, uh, the basic characteristics of what of mid-latitude cyclone. Okay, they can therefore go next, which I was saying I want to look at the stages that are necessary for development of mid-latitude cyclone. The stages that are necessary for the development of mid-latitude cyclone, and then one thing that we need to understand is that mid-latitude cyclones, they go through 4 stages from their initial formation to degeneration. They have got 4 stages from the initial formation, which we can say initial stage, up to their degeneration. The first 2 stages make up the process of cyclogenesis, which I explained that is the stage of developing and strengthening of a mid-latitude cyclone. So we are saying the first 2 stages, it forms up the cyclogenesis, that is the development and strengthening of a cyclone. In stages 3 and 4, the cyclone weakens and finally it disappears. So I'm just going to look at these stages one by one, and then this is just this is just a presentation or a photograph or a representation that you might sometimes find in a question paper, where you might be asked to identify, to see in this part, identify the various stages of mid-life cycle development that is illustrated on the diagram. So on this, or in our diagram there, we have got the stage 2, which is, I'm saying 2, we have got stage 2 there. We have got our stage 3, which is shown this side. We have got our stage 4, which is the occluded stage, the mature stage, stage 3, stage of development, stage 2, and initial stage, which are shown by various arrows or different arrows that I can label. Let me give them A, B, C. I can say A, B, C. So these arrows are demonstrating or pointing to a specific stage of cyclone development. So let's start with the initial stage. The initial stage, at the initial stage, what is happening there is that the polar front is stationary. We have got a boundary between 2 air masses, which we say that there is a polar front that is stationary there. And then what you are seeing, there is a boundary between the 2 air masses, which I can maybe label by putting the red ink here. The red ink here is showing or is demonstrating a stationary polar front. So boundary between the 2 air masses, that is the polar front that we are talking about. So what happens is that warm westerly and cold polar easterlies blow in opposite directions along the polar front. As you can see, these 2 air masses we have got, they are blowing to different direction. We have got different direction which the air masses are moving or blowing towards. So they are blowing in different direction, but towards what you call a stationary polar front. So the difference, the different air masses, they do not mix. The different air masses do not have the same density. they don't have the same temperature, and also obviously the humidity is different. So the air masses are different in various properties. The density, which is the amount, which is the weight of the air mass, the temperature, the humidity, amount of water vapor that they carry. Therefore, they do not mix it, and then friction develops between the two air masses. Friction develops between the two air masses, as you can see there. So the initial stage, we are just seeing two air masses moving parallel to each other, but towards the polar front that you can see there. So that is one thing that you are seeing. So we go to stage two, which you can see there by this arrow. It is showing the movement to stage two. Stage two, we have got the development stage, where we have a wedge, what we call a wave develops in the polar front. A wave develops in the polar front. A small mass of air, a small mass of warm air extends into the cold air, and it rises there. Therefore, the rising air causes low pressure at the center, or in the center that you are seeing. So what happens is you are seeing uh, the stage two is that it is actually in the developing stage, where we have got a kink, or we can say a kink or a wave that develops in the polar front, and then the wave develops because of the disturbance in the fast moving upper air winds, which I sometimes we need to know that they are known as jet streams that affect the movement of the air in the surface, and also because of the mountain range disturbances that it disturbs the motion of the air flowing over it. So a small mass of warm air extends into the cold air, and then the air rises over it. That warm air, it rises over it, which also saying the rising air causes the pressure to decrease. When air rises, the pressure decreases class. When air rises, pressure decreases because it's no longer in contact with the earth. Hence, the pressure decreases there. And then the rising air, we are saying it is establishing a center of low pressure that is developing there. In that regard, please note that again, there is the related weather conditions that are related, or that arises at stage its development stage. At the development stage, there are what you call weather conditions that are associated with it. These include, like we need to know that there are very cloudy weather and some rains which occur because of rising warm air, and then it forms clouds, which results in in rainfall. It results in cloud weather, some rain, which also is caused because of the warm rising air that is forming clouds there. So we have got stage three. Stage three is the mature stage. The stage three is the mature stage that you can see there. Stage three is the mature. It is the mature stage that you can see here. Stage three. So as you can see, we have got now our low pressure that you can see there. And you can see the pressure reading, which is now 1060, 1080, and then we can go up to 1010 going upward out there. So what is happening is the air is moving in a clockwise motion. This identifies that it is what? It is southern hemisphere, which is shown by the what? By the air masses that is moving. This is a clockwise movement that is being shown there. You understand? So the low pressure, it intensifies, it moves into the western belt away from the polar front, and then a well-developed cold and warm sector develops. A well-developed cold and warm sector develops there. As you can see, we have got our warm air, and then we also have our Our cold air. So we have got two sector, warm sector, and a warm sector and cold sector there. The cold dense air moves faster and causes the light air. The cold air moves fast, cold dense. Remember that cold air is denser than what? Than warm air. So cold dense air moves faster. It moves faster and forces the light, humid, less dense air in the in the warm sector to rise. The warm air in the warm sector, it is supposed to rise because this one we're saying it is dense, and then the cold sector becomes larger than the warm sector as the air moves and it leaves the warm air. The cold air moves and then it leaves the warm air. So in that respect, we have got what we have got the mature stage, which we can say that is in stage three. It is stage three. So in stage three, please note that we have got what? We have got our cold front, and then we have got our warm front. The home front is there. So please take note that the code front is given or is shown because we have got what? We are having those the symbol of like triangles that are resting on the line there, which are representing the code. It is representing the code front there. That is one thing that I want you to take note of. So class understands these things. The warm front is at the leading eastern edge of the warm sector. It is on the leading eastern edge of the warm sector, as we can see there. And then it is ahead of the warm air. It is ahead. As you can see, our warm air is there, and then our warm sector is in front. So, I mean, our warm air is behind, and then our warm front is ahead there. So the warm front, it is actually ahead. What you call the home front is actually at the leading eastern edge of the of the home sector. Therefore, it is ahead of the home air. The cold front, it is actually the leading edge of the of the cold air behind the home sector. Behind the home sector, as you can see, the cold front is behind the cold. I mean, the cold front is behind the home sector, which is on the leading edge of the of the cold air. So the whole process or the whole system, it moves from west to what? To east. It moves from west to east, as you can see. In sometimes you would see the diagram that would show is what you call spiral like direction of movement, which is showing a tail that develops to show that the air is moving from west to what? To east. It is moving from what? It is actually moving from west to east. That is one thing that you need to take note of. I also need you to understand one other thing, the specific weather conditions that are associated with what? With the mature stage. Weather conditions associated, weather conditions associated uh weather conditions that are associated with our stage three or mature stage, associated with mature stage in terms of development of mid-latitude cyclone, weather conditions associated with mature stage. In that case, I want you to know that there are specific weather conditions that are associated with it. There is rising air along the front that leads to condensation and cloud formation, which also results in what? In rainfall. We are saying rising air, we have got rising air uh, causing condensation, which is the cloud formation, and then we have got rainfall. We have got rainfall that is to form the, and then the rising air causes the pressure in the center of the mid-latitude cyclone also to drop further. We have got the dropping low pressure, low pressure pronunciation, or low pressure further development, low pressure center development, which is caused as a result of the of the rising warm air. And therefore, it further causes the warm, I mean the low pressure center development to be well pronounced. It becomes well pronounced there. And then one other thing is that this pressure is lower than it was in the initial stage. The pressure is even lower because what happens is the air rises, therefore it goes lower or even down than at the initial stage where we talked about that one. So airflow around the center in a cyclonic, which is a clockwise in the southern hemisphere, as I said there, which results in which direction that is that vary in different parts of what of the system. The winds are from the northwest in the warm sector and from the northeast ahead of the warm front, which I want you to understand that these are one other things that you need to take note of. So what I'm saying is that there is a variation in which direction that is in different parts of the what, which varies according to the different parts of the system. I'm saying which direction is according to the parts of the system, which is what northwest in what in warm sector, wind moves northwest in warm sector, air moves it moves northwest, air it moves in the northwest in the what in the warm sector. And what does it do in the cold sector? And also from the northeast ahead of the warm front. So what happens? It is northwest in the warm sector and from the northeast ahead of the warm front, and also southwest in the what in the cold sector. Southwest in the what in the cold sector, and southwest in the cold sector. That is one key. Those are key things that I want you also to take note of. Therefore, we can go to the last stage, which is also shown by this arrow representing that there is what we are going to stage 4. Stage 4, stage 4 is the occluded stage. Occluded stage. What happens there is that the warm sector continues to narrow. The warm sector, it continues to narrow. As you can see, it is because of the further upliftment that you are seeing. The warm sector, it continues to narrow, which if I was gonna label it, this is our warm sector. It continues to narrow. If you can compare it to the previous one, you could see that there is a difference that is from the mature stage to the occluded stage. The warm sector, it continues to narrow there. It continues to narrow or becoming smaller, and then the cold front overtakes the what? The warm front. At the cold front, it overtakes the warm front. The cold front overtakes the warm front, cold air, and then wedges under warm air. I'm sure you can see. This is the thing that you are seeing, the cold front here. It overtakes the warm front cold air. That is what is happening there, and then it wedges itself under the warm air. So what it does is that it is under, as to say, if I was gonna maybe put a line, I can say this is the point where we are saying in this part coming down like this, we have got what? We have got our cold front, which is also where we are having the cold air there. So what I'm saying is, please take note of these representations that are shown there, so therefore you can be able to clearly dissect and understand them. So the warm air then becomes isolated from the ground. The warm air becomes uplifted. The cold air, it wedges itself under the warm air. So this is called an occlusion. I told you occlusion is whereby it's a stage of cyclone development where we have got all the warm air being cut off from the ground. It is suspended into the atmosphere, and the lower part of the earth or on the ground is filled up with cold air, having only the warm air in the atmosphere. Then we have got an occluded stage. So please understand that the warm air is forced to rise, leaving only very small warm sector on the ground, and then the cold and warm front are joined, which you see there. The cold and the warm front are joined. This is what we are seeing. The cold and warm front are joined. Cold, we have got our cold and warm front. The cold and warm front are joined there. So what happens is that as they are joined there, we have got our symbol of occlusion, which is showing a combination of what occlusion, therefore, is shown by a combination of both of the symbols. I'm saying we have got a combination of both of the symbols where we have got that, and also we have this, as to say this is an occlusion or occluded stage, where we have got a combination of the symbols which are shown on the same front. They are shown on the same front, so which is representing both warm and cold front there. So the widespread rain occurs in the what in the warm as the warm air it rises along the occluded front, and then obviously we have got cools and contents is there, which results in what in clouds formation. So occlusion occurs finally because we have got all the warm air that is into the atmosphere or that is taken off the ground. That is one thing that should be understood there. To say stage 4 is occluded or occluded stage, we can understand that uh, finally, maybe other books or other authors, they have to talk about the stage 5, which is the dissected stage. Uh, this is the final stage of a mid-latitude cyclone, the dissected stage, whereby to say the cyclone is what is dying, or it is uh, fading away. So what happens, the cold front caught up the warm front along most of its length, and then it pushes what? It pushes the warm air of the warm sector upward in this final stage. So what we need to understand is that the entire warm sector is above the ground, which I explained that the entire warm sector or warm air is above the ground and there is no more warm air on the surface, which in this case we are saying no cold or warm air front are present. We no longer have warm or cold front present. This is because they are no more two distinctively different air masses. We no longer have distinct different air masses that are there. That is why we don't have warm and what cold air. I'm talking about stage 5, the dissecting or dissected stage. That is one thing that happens there. They are therefore, thus we can now talk about no boundaries are marked by fronts between the two air masses. Remember that boundaries or two air masses that are different are marked because of the presence of what? Of the fronts. So the isobars no longer, the isobars no, they no longer have the pattern of the mid-latitude cyclone, and they resume a regular pattern, which is because the mid-latitude cyclone is no longer present, hence it is what it is dissected. Uh, in that regard of stage 5, which sometimes is not there, it is actually supposed to know that there are light gusts of cold air which are found on the ground. Light gusts of cold air that are found on the ground can be the final thing that can be shown there. So please, class, what happens in the exam is that they always give you the stages. So you are supposed to know to say when you are given this stage 1, what is that is shown on stage 1, which you are seeing that this is what? This is initial stage. How does the initial stage look like? And then I'm saying we have got this photograph which has got arrows there. These stage 2, 3, and 4 are the most commonest one, which are mostly asked, where you need to know the development stage, the mature stage, and the occluded stage. Obviously, the occluded stage is not difficult. You are able to see it because you are seeing the narrowing, or you are seeing the fading away of the warm sector becoming smaller, and then we are having an occlusion that is existing on the ground there. That is how we distinguish it from what stage 2, stage 3, where we have got what? Where we have got the two different fronts that are quite far apart, illustrating a bigger warm sector that is present there. So thank you very much for your time, classy. I hope that you are going to understand and get this thing all right, and you will never make mistakes. You're gonna make this up to the final exams. All the best. I'm with you. Keep on following and also subscribing and liking our videos so that more can still be posted and keep coming. Have a beautiful day. Thank you once again.